is an initiative for class 10 students. I hope it will help you very much for your board exams. If you like this, don't forget to subscribe the channel. We have already learned combination reactions and decomposition reactions in the last section. And we used the general formula such as A plus B gives AB for the combination reactions and AB gives A plus B for decomposition reactions. I have already told you there are some conditions required for the decomposition reaction, such as presence of sunlight or the presence of dilute sulfuric acid or maybe of heating, etc. We see some more equations or what are the categories involved in the decomposition reactions and what are the conditions required or what we call these equations are. Let us see. The first two equations are called electrochemical reaction because the decomposition taken place only when electricity is passed through. And the next two equations can be called photochemical reaction because this reaction carried forward only in the presence of sunlight. And the last reaction taken place by heating. So it is called thermal decomposition reactions. Next is displacement reaction. Before going to the displacement reaction, we must know the reactivity series of metals. Here the reactivity series of metals are displayed here. You see potassium, sodium, calcium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver, gold and platinum are displayed here. You see hydrogen is here among the metals. Why hydrogen here among the metals? There is a doubt. Oh, why hydrogen is here among the metals? Because hydrogen has a dual nature there. Hydrogen shows a metallic character, that means H plus ion, a metallic nature as well as a non-metallic nature. Since it has a metallic nature, hydrogen is included in the reactivity series of metals. During a displacement reaction, a more reactive element displaces a lesser reactive element from the salt solution. See some examples. See the reaction between solid iron with aqueous copper sulfate, that is copper sulfate solution. Okay, so we have two metals. Iron and copper. So look at the reactivity series. Which one is more reactive? We see iron is more reactive since iron comes before copper in the reactivity series. So the more reactive iron displaces the less reactive copper. That means the copper goes out. So an iron comes along with sulfate. That means iron sulfate, FeSO4. It is a liquid solution form. Okay, rather we say it is a solution. FeSO4 solution, ferrous sulfate solution. And see, the question comes as what the observation here? Okay, you may be asked to write the observation. So since it is blue color solution and iron is grayish black and blue color solution. But the first observation is that the blue color solution changes to green color. Okay, and you see there are brown colors copper particles appear. Two observations are there. The blue color solution changes to green color and there are brown particles of copper appear. See the next equation. We have two metals, zinc and copper. As we know, sulfur and oxygen both are non-metals. The more reactive zinc displaces copper. Look at the reactive series. After the zinc, the copper comes on the reactivity series. Okay, so copper out, then who comes? Zinc comes here, so it becomes zinc sulfate. Okay, a blue color solution, it is aqueous solution. Aqueous solution means the salt is dissolved in water. Okay, blue color aqueous solution changes to a colorless aqueous. Zinc sulfate is a colorless solution. As I have already told you, the color of copper is brown. The brown particles of copper appeared. Okay. See the next two. Copper is more reactive than silver. Look at the reactivity series. Copper is more reactive than silver. That means copper comes first, thereafter silver in the reactivity series. The copper displaces silver. So silver is made out. Then copper comes here. That means copper and nitrate. Copper and nitrate forms copper nitrate. CuNO3 all twice. Copper nitrate. Next is double displacement reaction or double decomposition reaction. Okay. See, there can be a general formula. AB plus CD. AB is an ionic compound. Ionic compound in the sense it can have a positive side and a negative side. You see, NaCl is an ionic compound. It has a metallic side and a non-metallic side. The metallic side can be called a positive ion and the non-metallic side can be called a negative ion. So it is suppose we consider it as a ionic compound. So A can be positive and B can be negative. The same way C can be positive and D is negative. Okay. So when they react each other, 2 times the displacement takes place. That's called a double displacement. 2 ions are getting displaced. A react with the positive one, react with the negative one of the next compound. And the positive of the another one react with the negative of the first one. So what are the products? You see A and D. A, B plus C, B means BC. Such a way it can be represented. See, AgNO3, silver nitrate. In the aqueous form, it is a colorless solution. It is an ionic compound, colorless ionic compound. React with sodium chloride, NaCl, aqueous form. It is also colorless. Sodium chloride is there in our home, common salt. So what we get? It is positive, it is negative. We can divide such a way. Positive and negative. So positive silver goes with the negative chlorine. That means AgCl, which is a solid precipitate, which is in white color, white solid. Plus what we get? Sodium with the nitrate. Sodium and nitrate is called sodium nitrate, NaNO3. NaNO3, it is in the aqueous form. One product is in the solid form and another is in the aqueous form, which is a colorless one. Colorless. So what is our observation? When 2 colorless ionic compound react to each other, we get a white solid, a white precipitate. Okay. See another example. Barium chloride solution. A barium chloride aqueous solution we write as AQ, aqueous. It's a colorless solution. React with sodium sulfate, Na2SO4. Sodium sulfate solution we write AQ, aqueous. It's also a colorless solution. A colorless solution. Okay. See, as I told you, it can be positive. Metal, barium is a metal positive. Chlorine is a non-metal minus, negative. Sodium positive and sulfate. Sulfate is a radical, SO4, 2 minus. We studied in 9th class. Sulfate is a radical, negative radical. So the positive barium goes with the negative sulfate. That means we get BaSO4. Okay, BaSO4. It is a precipitate, white. It is a white colored precipitate, solid. So for precipitate we can give a downward arrow mark or we can write as S in bracket, as we can see in the previous example. Plus sodium positive goes with the chlorine. Okay. So sodium chloride is NaCl. For writing the formula, we always use a crisscross method. Okay. Don't write as Na2Cl2. Here Na2, here Cl. Don't write. It's wrong. Because use the method of crisscross method as the valency of sodium is +1, valency of chlorine is -1. The crisscross we get Na1Cl1, and if it is 1, we don't normally write the numerical ones while writing the chemical formula. So NaCl, which is soluble in water, so it can be called aqueous and it is colorless. So what is the observation? Barium, the two colorless reactants react each other to give you a white colored solid, a precipitate, barium sulfate. Learn these equations, and all the equations are important for the board exams.